September 30th, 2025, 23:59 Coordinated Universal Time. The air above the Jet Propulsion Laboratory in Pasadena felt heavy, not with the typical California smog, but with a tension far more bureaucratic. Just 1 minute later, the quiet click of a budget mechanism running dry shut down the world's most advanced space agency, NASA's primary communication pipeline. The one that routinely delivered real-time telemetry from a dozen interplanetary missions, shuttered by 0:01 on October 1st. The agency's central website, the digital hearth of human space exploration, was replaced by a static, stark message. NASA is currently closed due to a lapse in government funding. It was a blackout of convenience, a total information vacuum descending upon the one entity capable of making sense of the sky. And it was at precisely this moment, the moment the public was definitively blinded, that the most compelling interstellar visitor in modern history, an object designated 3I/Atlas, made its closest, most critical approach to the Martian planetary system. This was not a matter of a few kilometers. It was an astronomical handshake, 30 million kilometers separating the hypervelocity traveler and the red planet. Yet for our scientific purposes, this was the optimum observation window, the critical 7-day period when our orbiters, our expensive, highly calibrated robotic eyes, were perfectly positioned to study an object born around another star. For any normal celestial event, this would have triggered a global media frenzy. NASA TV would have run a continuous stream of updates. JPL social media accounts would have been flooded with mission planning details. Instead, there was absolute silence. The public was told it was Tuesday in Washington, just political gridlock. But here's the unsettling truth that kept mission scientists awake through the initial days of the shutdown. The timing of the federal blackout was so profoundly perfect, it felt less like bureaucratic chaos and more like a prearranged, high-stakes isolation protocol. The sudden, total cessation of NASA's public data flow was merely the stage setting for an unprecedented discovery. Because 3I/Atlas was not acting like a typical interstellar comet, we first picked it up in July, an object exhibiting a clear coma, a fuzzy atmosphere of gas and dust, suggesting active outgassing, that put it in the same class as the second visitor, 2I/Borisov. But there was a growing discrepancy between the object's predicted orbital path, calculated solely on solar gravity and basic outgassing models, and its observed trajectory. The data suggested a tiny, persistent push, a non-gravitational acceleration that was too high, or worse, too irregular, to be easily dismissed as simple water ice sublimation. Astronomers were already raising alarms, noting that something was subtly propelling the object, and it was at the peak of this unexplained motion, at its closest pass to a planet hosting a fleet of sensitive observers, that NASA's communication links went dark. The true moment of alarm, the unidentified movement that has fueled the most intense private debates, occurred roughly 72 hours into the shutdown at the European Space Agency's Control Center, where the Mars Express and the ExoMars Trace Gas Orbiter teams were operating normally. Preparations were underway for a short, high-resolution spectroscopy burst aimed at the comet's nucleus. This was the moment of maximum scientific return. A brief, high-bandwidth connection, a direct downlink, was scheduled through the Deep Space Network's Australian dish to capture the raw data. This was the window that mattered. But as the Mars Express began its programmed sequence, targeting the comet's faintly visible nucleus, the telemetry stream, which was scheduled to run for 180 seconds, interrupted for an unknown reason at the 97-second mark. The screens at ESA went dark on the crucial data channel. The rest of the stream, which included instrument diagnostics and basic housekeeping data, continued normally. The interruption was selective, impacting only the high-value science telemetry. Experts are calling this the most enigmatic cosmic anomaly to date. Was this a technical failure or a calculated, almost surgical termination of a data stream that was about to show something no one expected? The government may have shut down, but the universe hadn't, and what happened in the void of that silence is what we need to investigate next. The fact that NASA's data pipeline was officially closed gives every organization involved the perfect cover to compartmentalize and archive what they saw. Let me now explain precisely what we were dealing with when the lights went out in Washington. 3I/Atlas is not merely a passing rock. It is a certified interstellar object, the third ever confirmed following the bizarre cigar-shaped 1I/Oumuamua in 2017 and the far more conventional 2I/Borisov in 2019. The designation 3I confirms its origin. An object traveling on a decidedly hyperbolic trajectory, meaning its speed is so immense the sun's gravity is insufficient to capture it. It has swung around our star once and is now on a slingshot path back into the deep void between star systems, never to return. This alone makes it one of the most scientifically valuable targets in human history. It is a pristine sample, untouched by the long, repetitive gravitational cycle of our own solar system, offering a glimpse into the chemical makeup and formation processes of a distant stellar neighborhood. But 3I/Atlas presented two immediate paradoxes that set it apart from its predecessors. The first was its activity, unlike Oumuamua, which exhibited no detectable coma or tail, suggesting it was an inert asteroid fragment. 3I/Atlas was clearly an active comet. Discovered by the Atlas Survey System in July 2025, it quickly developed a visible coma and a short tail, indicating it was shedding volatile materials, ices like water, carbon monoxide, or carbon dioxide. As it approached the sun, this activity was crucial. It provided a natural explanation for any slight deviation from a purely gravitational orbit, the rocket-like effect of outgassing. This seemed, initially, to calm scientific nerves, placing the object firmly in the Borisov camp. Strange origin, but normal behavior. The second paradox, however, was the inconsistency of that very activity. Early observations from the Hubble Space Telescope in late August provided the first high-resolution constraints on its size. The nucleus was estimated to be quite small, likely less than 2 kilometers in diameter, but the non-gravitational acceleration, the tiny thrust detected from the outgassing jets, seemed disproportionately high for a nucleus of that size. The mass loss rate required to produce the observed thrust should have resulted in a far brighter, more turbulent coma than what was actually imaged. We faced a conflict. Either the object was far denser than a typical comet, meaning it wasn't mostly porous ice and rock, or the acceleration was not entirely due to simple sublimation. It hinted at jets that were highly localized, highly efficient, or worse, non-standard. This growing scientific uncertainty was amplified by the object's specific geometry upon arrival at the inner solar system. 3I/Atlas reached its perihelion, its closest approach to the Sun, around October 30th, 2025, but the most important event occurred weeks earlier. The Mars Close Encounter on October 3rd, just 3 days into the NASA shutdown. From the perspective of Earth-based telescopes, 3I/Atlas was suffering from low solar elongation during this critical week. It appeared too close to the sun in the sky, making direct observation virtually impossible due to the overwhelming glare and the risk to sensitive ground instruments. The Earth was effectively blind. This elevated the Martian orbiters, the assets controlled by the very agency currently locked in administrative silence, from valuable collaborators to the sole eyes on the object. The geometry was spectacular. 3I/Atlas would pass approximately $0 from Mars, or 30 million kilometers. While vast by human standards, this was 100 times closer than its approach to Earth and offered an unparalleled perspective. Our orbiting spacecraft, particularly the Mars Reconnaissance Orbiter, MRO, with its high-resolution imaging science experiment, HiRISE camera, and the European Trace Gas Orbiter, TGO, with its Nomad spectrometer, possessed the necessary vantage point and instrumentation. They were looking at the comet from a near-optimal, side-on angle, free from solar glare. They had the unidentified movement under their lens. It is this conjunction, the third interstellar visitor, its anomalous behavior, the perfect observation geometry, and the total public communication blackout, that compels this investigation. The crucial data, the definitive answers regarding the object's true nature, and the source of its unnerving push rests in the memory buffers and isolated access archives of systems that were legally prohibited from sharing information. It forces us to ask, what did those cameras see during the 180 seconds of attempted observation? And why did the most critical 97 seconds of the downlink cut out? The coincidence is too perfect to dismiss as mere political theater. It feels scripted, and the script was designed for one audience only. The few individuals still considered accepted personnel during a time of national operational paralysis. This wasn't just a lapse in funding. It was a lapse in the very mechanism of transparency. It created a situation where data could be collected and analyzed, its significance understood, without a single public affairs officer being authorized to issue a press release or update a frozen website. The official silence provided a legal, clean mechanism for non-disclosure. We need to look closely at the precise nature of this silence, the legal framework that suddenly turned an open, collaborative, scientific endeavor into a highly compartmentalized operation. To understand the unsettling quiet that swallowed the 3I/Atlas encounter, one must first dissect the legal iron cage of the U.S. government shutdown. This was not a power failure. It was a systemic paralysis dictated by the Anti-Deficiency Act of 1884, a federal law strictly prohibiting agencies from spending or obligating funds that Congress has not yet appropriated. Violation of this act, even by accident, can lead to serious legal consequences for federal employees. This law is the legal backbone of the informational blackout, and it is far more effective than any clandestine censorship order. Under NASA's own publicly accessible continuity of operations plan, most personnel are immediately furloughed. This includes the entirety of the Office of Communications, the Public Affairs Branch, web developers, and most non-essential scientists, engineers, and administrative staff. The result is a total and immediate cessation of all public-facing activities. Websites like nasa.gov, the Jet Propulsion Laboratories mission pages, and the raw image browsers for Mars orbiters do not just stop updating. They often freeze entirely or are replaced by the single, official closure notice. For the average person scrolling through news feeds, the data simply stops flowing. But here is the critical distinction that allowed the surveillance of 3I/Atlas to proceed in absolute privacy. Operational continuity. The same continuity plan mandates that activities necessary to protect life and property must continue. This is the legal loophole that kept the lights on in Mission Control, the International Space Station, ISS. Crews must be kept safe. Crucial Earth-observing satellites must be monitored to prevent collision or loss. And, most pertinent to our mystery, the 2.5 billion worth of assets orbiting Mars. The Mars Reconnaissance Orbiter, IMRO, MAVEN, and others must be maintained. During the shutdown, a minimal crew of accepted personnel, flight controllers and essential safety engineers, remain on duty. Their job was strictly to ensure spacecraft health and execute pre-approved, safety-critical maneuvers. They were legally prohibited from conducting new science, writing press releases, or updating the public. They were, however, receiving streams of housekeeping data, diagnostic information verifying the spacecraft's health, power status, thermal readings, and antenna pointing angles. Crucially, they also oversaw the movement of high-volume data packets from the orbiters to the Deep Space Network, DSN. If the MRO was already pre-programmed before the shutdown to target 3I/Atlas, an entirely plausible scenario given the scientific importance. The resulting imagery and spectrometer readings were still collected and downlinked. The data was not lost. It was simply intercepted by a pipeline that had been surgically severed from the public endpoint. The data packets landed on servers at the DSN and JPL, not in the hands of the public affairs specialists, but in the hands of a minimal, legally bound crew whose only mandate was to archive and safeguard the property. This created an unprecedented asymmetry in information access. On one side, the public and the majority of the scientific community saw a single, frozen screen. On the other, a small, highly compartmentalized group of engineers had access to high-quality, raw science data concerning the third interstellar visitor at its closest approach to Mars. just as early reports suggested it was exhibiting unidentified movement. The optics of this situation are damning. The sudden, total silence from the world's leading space agency, coinciding precisely with a globally significant celestial event, fueled immediate and rampant speculation. Online communities, already primed by the Oumuamua debates, saw the shutdown not as administrative friction, but as a covert protocol for isolating access to potentially sensitive information. It allowed any anomalous data to be vetted, analyzed, and potentially neutralized before it ever entered the public domain. The term telemetry gaps became the currency of online discussion. Were they genuine transmission errors, or were they moments when the data stream, the straight pipe from the DSN receiver, was being intentionally diverted into a secure, classified buffer before hitting the public-facing archive? The 97-second cutout during the critical Mars Express downlink, while theoretically manageable for ESA, which was operating independently, suddenly looks less like a hardware glitch and more like a systemic disruption targeting high-value scientific products. If that data, now held in an isolated access buffer, contained confirmation of the object's strange motion or unusual composition, the perfect timing of the NASA shutdown means no one outside that small, accepted group would know. The only verifiable fact is the silence itself. The question is what secrets that silence is keeping. We must now turn our attention to the fleet of observers at Mars and analyze exactly what they were capable of seeing during the Great Blackout of October 2025. To appreciate the sheer volume of data potentially collected and subsequently sequestered during the October 2025 blackout, we must detail the operational fleet position of Mars. The Red Planet is currently host to an international armada of orbiters, each equipped with instruments capable of scrutinizing 3I/Atlas with astonishing precision. We can refer to this collective observing capability as the Mars Hexagon, a set of critical assets poised for the observation of unidentified movement, free from Earth's solar obstruction. On the American side, under the jurisdiction of the shutdown-paralyzed NASA, lay two primary observation platforms. First, the Mars Reconnaissance Orbiter, (MRO). Launched in 2005, MRO is often called the Hubble of Mars. Its standout instrument is the high-resolution imaging science experiment, HiRISE. HiRISE is a powerful telescope capable of resolving features on the Martian surface as small as 30 centimeters from its orbital altitude, while 3I/Atlas was 30 million kilometers away, far beyond the range for resolving surface features. HiRISE possessed the angular resolution and sensitivity to capture precise photometric data. Specifically, it could measure the comet's brightness variations over time, any rotational anomalies, any sudden flares of activity, or any structured shape in the coma. All signs of non-standard behavior would be registered in the HiRISE data buffer. Second, NASA's MAVEN, Mars Atmosphere and Volatile Evolution mission, while primarily designed to study the Martian upper atmosphere and the solar wind's influence, MAVEN is equipped with sophisticated magnetometers and particle detectors. Though it could not image the comet, its sensors would be sensitive to any changes in the interplanetary plasma environment caused by the massive outgassing or particle emission from 3I/Atlas. If the object possessed an unusual magnetic field or was emitting large amounts of non-cometary charged particles, MAVEN would have been the first to record this inconsistency in the local space weather. This data, highly technical and esoteric, would be immediately routed through the isolated access pipeline reserved for mission-critical diagnostics. Across the operational aisle, the European Space Agency, ESA, deployed its own powerful fleet, which crucially remained fully funded and operational during the NASA blackout. This included Mars Express, a veteran orbiter carrying the high-resolution stereo camera, HRSC, capable of wide-angle context imaging and coma analysis. More critically, the ExoMars Trace Gas Orbiter, TGO, a newer asset, carried the NOMAD, nadir and occultation for Mars Discovery, Spectrometers suite. NOMAD's purpose is to analyze the chemical composition of the Martian atmosphere, but its sensitivity is ideal for analyzing cometary outgassing if 3I/Atlas was venting unusual materials. such as the highly speculative claims of elevated metals or industrial compounds. NOMAD was the instrument best positioned to capture definitive spectral signatures. ESA's public statements confirmed an active, planned campaign utilizing both TGO and Mars Express between October 1st and October 7th. They openly discussed their goal to obtain the first high-resolution spectra of an interstellar object taken from a planetary vantage point other than Earth. This is where the tension becomes acute. ESA was transparent about its intent. Yet the crucial 97 seconds of their high-bandwidth science downlink was surgically terminated. Was this due to interference from a co-located NASA asset performing an unannounced protocol? Or was the termination a remote decision made at a DSN relay point, which is jointly operated, to prevent the highly sensitive data from reaching even the public-facing European archive? The logistical difficulty of observing 3I/Atlas from Earth, compounded by the shutdown, meant that the data collected by MRO's HiRISE and TGO's NOMAD during that one-week window are effectively irreplaceable. They hold the definitive record of the comet's behavior, its spin, its brightness, its chemical composition. At the peak of its anomalous activity, this data, particularly the HiRISE photometric readings, which are crucial for detecting minute changes in angular position and rotational period, is the key to proving or disproving the presence of unidentified movement. During the shutdown, the housekeeping data passing through the isolated access pipeline confirmed that MRO was operational and that its systems were healthy. The flight control teams, though legally prohibited from confirming science data acquisition, would have noted if the pre-programmed observation sequences had failed. Therefore, the most logical and unnerving conclusion is that the data was collected. It simply bypassed the public stream and was directed into the classified storage facilities at JPL, labeled under an accepted operations protocol, an inconsistency that protects the asset but simultaneously shields the data from public view. The real mystery now pivots from whether the observations occurred to where the raw files reside. Are they tagged with a routine shutdown-affected delay, awaiting the return of furloughed scientists? Or are they permanently marked with a classification that dictates permanent compartmentalization? The silence wasn't due to technical failure. It was due to a legal, bureaucratic mechanism that proved to be the most effective mechanism for achieving immediate, profound non-disclosure, precisely when the universe offered a spectacular secret. The most immediate and jarring element of the 3I/Atlas investigation is the sharp operational and ethical discrepancy between the European Space Agency, ESA, and its American counterpart during the critical October week. While NASA was constrained by the Anti-Deficiency Act, ESA's Mars assets, Mars Express and the ExoMars Trace Gas Orbiter, TGO, operated on a standard, predictable schedule, completely outside the jurisdiction of a U.S. government shutdown. This created a profound contrast, a beacon of transparency shining directly onto the void of American silence. ESA's mission was explicitly publicized before October 1st. Press releases and interviews with lead scientists detailed their ambitious plan to use the TGO's highly sensitive NOMAD spectrometer and the Mars Express's HRSC camera for an intensive 7-day observation campaign. The goals were clear: to capture high-resolution spectra of the cometary coma, to determine the precise ratios of volatile materials, water, carbon monoxide, methane, and to search for any exotic molecular signatures. This was the open, collaborative science the world expected. The crucial event, however, remains the inexplicable cutout of the high-value science data stream. At the moment TGO initiated its most sensitive spectroscopic scan, aligned perfectly with the comet's nucleus, the data transmission was severed at the Deep Space Network, DSN, receiving station. It is vital to note that the DSN, while technically a NASA asset, operates as a shared international resource, frequently handling data from ESA missions. The DSN is the funnel for all the Mars data, and it is here that isolated access protocols could be implemented without arousing suspicion at the ESA control centers. ESA immediately reported the telemetry interruption as a transient communication issue. Yet, The inconsistency of the failure is what raises the immediate red flag. The interruption was not a total system failure. The housekeeping data, the low rate, diagnostic information confirming TGO's health and pointing angle, continued. Uninterrupted, only the high-bandwidth science payload, the spectral data that would reveal the comet's composition and unidentified movement, was lost for those critical 83 seconds from the 97 seconds mark to the pre-programmed end. This selective failure suggests an intervention that was less about a random technical fault and more about a calculated protocol override. If the DSN, operating under the severe constraints of the NASA shutdown, detected a spectral signature in the raw, unencrypted TGO data that was deemed sensitive, perhaps the unusual metal signatures previously alluded to, it is entirely plausible that an accepted personnel team at the DSN station enacted a prearranged security measure. This measure would not involve overtly censoring or deleting the data, which would be illegal and leave a clear trail. Instead, the data stream could have been rerouted in real time into a classified archive buffer, temporarily starving the public ESA feed. This scenario does not require a complex, malicious conspiracy. It requires only a protocol if the U.S. military or intelligence community, agencies that remained fully funded, had pre-briefed NASA's DSN accepted personnel on specific trigger conditions, say, the detection of strong spectral lines for specific high-density elements or unusual radio frequency inconsistencies. The shutdown provided the perfect, plausible cover for executing that pre-brief contingency plan. The result: the European scientists were left with diagnostic confirmation that they tried to observe the comet, but without the definitive, crucial spectral results. Furthermore, the European transparency itself offered a strategic advantage to the American side. During their self-imposed blackout, ESA openly published its planned observation schedule, including precise pointing angles and timeframes. This information served as a perfect blueprint for NASA's accepted personnel to verify which of their own assets, MRO, MAVEN, were concurrently observing the comet. If MRO was running a pre-programmed high-rise sequence at the exact time TGO's downlink failed, then the MRO data becomes the definitive, sequestered record of the event. The high-rise camera, while not a spectrometer, is incredibly sensitive to brightness and shape. If TGO's Nomad was about to confirm unusual chemistry, MRO's high-rise could have captured the visual effects of that chemistry, perhaps unusual jetting, a highly reflective surface, or a structured rotational anomaly. The compartmentalization of a U.S. system, combined with the predictable openness of the ESA, created a scientific trap. The full picture was obtained, but locked behind a wall of legal and operational silence. The true significance of the ESA anomaly is the realization that the informational silence was not universal. It was a U.S.-centric phenomenon, and by contrasting the full openness of one major partner with the total blackout of the other, the circumstantial evidence for deliberate isolated access to the most critical data becomes impossible to ignore. We must now define the precise nature of the dead zone created by this synchronization failure and determine exactly why the lack of terrestrial access made the data from that week the most sensitive commodity in the solar system. The scientific community refers to the period between October 1st and October 7th, 2025, as the dead zone. This phrase is not merely metaphorical. It accurately describes the total collapse of effective, public-facing observation capability regarding 3I/Atlas. This unique informational vacuum was the result of a devastating combination: adverse celestial geometry and the engineered bureaucratic paralysis of the U.S. government. Understanding the dead zone is key to appreciating why the data collected by the Mars orbiters during this single week is now the most critical archive in question. First, the geometric constraints for Earth-based observers. The vast majority of professional and amateur telescopes, 3I/Atlas was rendered virtually invisible due to extreme low solar elongation. From our perspective, the comet appeared to hug the limb of the sun, meaning it was visible only briefly, low on the horizon, immediately after sunset or before sunrise, attempting to observe a faint, fast-moving object under these conditions is hazardous and scientifically inefficient. The overwhelming glare from the sun saturates detectors, introduces massive atmospheric turbulence, and risks permanent damage to sensitive optical equipment. This meant the global astronomical community was forced into a state of temporary operational blindness. The only way to bypass this solar glare was to observe the comet from a different vantage point in the solar system, a place where the sun was not in the background. That place, of course, was Mars. The Martian orbiters, the MRO, MAVEN, Mars Express, and TGO, possessed the necessary geometry advantage. They were looking at 3I/Atlas from a perspective where the solar glare was minimal or non-existent, providing a crisp, dark sky view of the comet at its point of closest approach. The Mars window, peaking on October 3rd, was therefore not just an opportunity. It was the sole opportunity to gather high-fidelity data on 3I/Atlas until its post-conjunction reappearance in late November. The uniqueness of this window cannot be overstated. Any confirmation of unidentified movement or spectral inconsistency hinged entirely on the observations collected during these 7 days. Second, the bureaucratic paralysis. The NASA shutdown perfectly synchronized with this unique geometric window. The legal requirement for silence meant that even if MRO's high-rise captured definitive visual evidence of structure rotation, a light curve that suggested an elongated, tumbling object, or, more speculatively, non-natural geometry, the public would not know. The only personnel authorized to handle the resulting raw data were the accepted personnel, the flight controllers and safety. Engineers whose primary concern was asset protection, not science dissemination. This led to the immediate establishment of isolated access to the data stream. Any raw packets arriving from MRO or MAVEN during the dead zone were necessarily routed into a secure, internal archive buffer, bypassing the standard public data pipelines, which were officially offline. This process, while procedurally clean under the Anti-Deficiency Act, resulted in the compartmentalization of the most sensitive scientific data. Data flowed from the distant planet, through the DSN, and into a deep, dark well of governmental storage. The immediate consequence of this vacuum was the proliferation of unverified claims, particularly concerning the MRO's operational status. Reports circulated online that raw image directories, which sometimes briefly appear before being officially vetted and processed, were populated with high-rise thumbnails that were either immediately pulled down or contained strange artifacts. While most of these were dismissed as noise generated by the information drought, the fact is that without a functioning NASA Public Affairs office to confirm or deny, every rumor gained equal weight. The discrepancy between what was known, ESA was looking, and what was silenced, NASA was looking but couldn't talk, created the perfect environment for these narratives to flourish. The crucial metric is the data group contrast. We know that some data was collected, particularly housekeeping and safety telemetry. We also know that the instruments were physically capable of observing the comet. The question, which only the post-shutdown analysis can answer, is whether the resulting science data, when eventually released, will show a non-proportional gap during the dead zone. If, for instance, HiRISE released thousands of images from September and December, but only a handful of low-priority, non-comet frames from the critical first week of October, that absence would speak volumes. It would strongly suggest that the high-value 3I/Atlas data was not simply delayed, but was subject to an unannounced protocol, a permanent diversion into an internal, classified silo. The dead zone was, therefore, the perfect confluence of astronomical opportunity and bureaucratic failure. It was the week where an interstellar object exhibiting subtle, unidentified movement was placed under the exclusive, non-public scrutiny of a handful of legally constrained government employees. The data from this period is the ultimate prize, and its fate, whether it's simply delayed or permanently sequestered, is the central focus of our ongoing investigation. We must now turn our attention to the specific technical inconsistency that first alerted observers to the object's non-standard behavior, the rotational anomaly. The first truly compelling evidence that 3I/Atlas was performing unidentified movement beyond the standard gravitational and outgassing models, came not from the Martian orbiters, but from dedicated ground-based photometric observations conducted in the late September window, just before the comet's unfavorable solar elongation began. This movement manifested as a deeply unsettling spin anomaly embedded within the object's light curve. A light curve measures the brightness of a celestial object over time. For a comet, fluctuations are typically caused by two primary factors: changes in distance from the Sun, which affects overall activity, and the rotation of the nucleus, since most cometary nuclei are irregularly shaped, often described as fluffy, porous rubble piles. Their rotation causes periodic brightening and dimming. This is the predictable inconsistency of a natural body. An irregular shape produces irregular, predictable rotational period. However, the light curve data collected from observatories like the Las Cumbres Observatory Global Telescope, (LCOGT) network in the days leading up to the dead zone exhibited a highly anomalous signature. The primary rotational period was measured at roughly 10.5 hours, which is a common range for small comets. But superimposed on this expected periodicity was a secondary, shorter cycle, a 1.8-hour oscillation that did not correlate with any known natural process, such as tumbling or precession. This secondary, fast oscillation created a distinct discrepancy. If the object were a normal, elongated comet, the light curve should reflect the rotation of the principal axis. The presence of a separate, rapid flicker suggested something structural or highly localized was rotating independently or emitting light non-uniformly. Traditional cometary physics offers limited explanations for such a tight, rapid, short-period oscillation. Could it be a binary system? Highly unlikely given the size constraints. Could it be a fragment that broke off? Possible, but the stability and persistence of the 1.8-hour signal argued against a chaotic fragmentation event. The most disturbing possibility, immediately discussed in isolated access forums used by specialized dynamics teams, was that the anomaly pointed toward structure, a geometrically regular, manufactured object, perhaps a probe with a highly reflective panel or antenna, could create such a precise, fast flicker as it rotated or was actively modulated. While this falls into the realm of the extraordinary hypothesis, the data was there, a persistent, rapid, unidentified movement embedded in the object's most fundamental physical characteristic. This is where the Martian orbiters, particularly MRO's HiRISE camera, became absolutely crucial during the dead zone. HiRISE was tasked with collecting a series of long-exposure photometric sequences precisely to confirm and refine this light curve. The data collected by HiRISE would be the definitive word on the spin anomaly. Because of the excellent geometry advantage from Mars, HiRISE could observe the comet continuously, without the periodic interruptions of the Earth's day-night cycle, and without the degrading effects of atmospheric turbulence. If the 1.8-hour oscillation was real, MRO's data would capture it with unprecedented clarity. Furthermore, the HiRISE team was likely looking for more than just brightness variation. They would have been looking for subtle evidence of coma asymmetry, a visual distortion in the gas cloud that would betray the source of the force causing the object's slight, non-gravitational push. If the anomaly was due to highly efficient, localized jets of material, perhaps venting from specific, tiny, warm spots, the HiRISE imagery would capture the resulting plume or jet fan. If, however, the object was structurally uniform and the acceleration was non-propulsive, then the mystery deepens profoundly. The problem, of course, is that the entire HiRISE observation sequence occurred during the dead zone. The resulting high-value photometric data, which could confirm or falsify the nature of the 1.8-hour spin anomaly, was immediately routed into the secure archive under the Accepted Operations Protocol. This created an immediate knowledge gap. The scientists who proposed the observation were furloughed. The flight controllers who executed the observation were legally prohibited from opening the science files. The raw HiRISE files, now held in a classified silo, are the definitive pieces of evidence concerning the spin anomaly. If and when these data packets are released, we must look for specific metadata markers. Were the exposure times consistent? Did the camera maintain pointing lock? Or was there subtle evidence of rapid, high-frequency, unidentified movement that the tracking system struggled to follow? The subsequent official silence from NASA regarding the rotational characteristics of 3I/Atlas, even after the nominal end of the shutdown, is a loud, technical signal that the data may have contained something highly problematic. The absence of confirmation regarding the 1.8-hour period in any official statement suggests that the information was deemed too sensitive to be released, even after vetting, ensuring its permanent compartmentalization. The key to understanding how vital information regarding the unidentified movement of 3I/Atlas was successfully contained during the public blackout lies in dissecting the architecture of the Isolated Access Protocol. This protocol is not a single, malicious act of censorship. It is a meticulously designed bureaucratic mechanism that transforms the physical flow of data into a highly selective, compartmentalized knowledge system. It functions entirely through legal compliance, utilizing the very real constraints of the government shutdown to its advantage. The protocol begins at the Deep Space Network, DSN, receiving stations, specifically the 70-meter dishes in Canberra, Australia, and Goldstone, California, which were handling the Mars data flow. During the shutdown, these facilities remained active, staffed by a skeleton crew of accepted personnel. Their primary legal mandate was the safety and integrity of the assets. They were the physical custodians of the data, the guardians of the black buffer. When MRO, or TGO, downlinked its data, the raw signal arrived at the DSN antennae. This signal contained two distinct streams: the low-rate housekeeping data, temperature, voltage, pointing angle, and the high-rate science telemetry, high-rise images, nomad spectra. Under normal operations, both streams are immediately routed to mission-specific servers at JPL, where they are automatically formatted and placed in a temporary buffer awaiting public dissemination and scientific analysis. Under the Isolated Access Protocol, which was enacted legally via the Continuity of Operations Plan, this dual-stream routing was surgically altered. The low-rate housekeeping data, critical for asset safety, continued its normal path, ensuring flight controllers could confirm the orbiters were alive and well. This satisfied the legal requirement to protect property. However, the high-rate science telemetry was subject to an unannounced protocol. It was diverted. Instead of being placed in the standard, publicly accessible buffer, it was routed into a separate, secure internal server, often referred to within certain circles as the classified silo or the black buffer. This routing was justified not by direct scientific censorship, but by an interpretation of the law. Since furloughed scientists could not immediately process the data, and since the data itself was not critical to immediate spacecraft survival, it was deemed an unnecessary expenditure of time and resources to place it on a public-facing system that would require maintenance and monitoring. Therefore, the most prudent, legally compliant action was to archive it securely until regular operations resumed. The effect of this legal maneuvering was profound. The handful of accepted personnel, those still working, had physical access to the raw files. They could confirm the data existed. They could run basic integrity checks on the FITS files, flexible image transport system, the standard format for astronomical images, ensuring the data blocks were complete, but they were strictly prohibited from analyzing the scientific content. They were glorified librarians, legally bound to silence, sitting atop a mountain of high-value, sensitive information. This operational framework successfully achieved profound compartmentalization. It completely severed the science data from the political and media environment. Any evidence confirming the 1.8-hour spin anomaly or the highly unusual spectral inconsistency, which we will discuss next, was isolated from the public, from the media, and most importantly, from the majority of the scientific peer review community. The only way the public became aware of this diversion was through the resulting discrepancy in data logs. In the weeks leading up to the shutdown, the publicly viewable DSN scheduling and log file showed expected volumes of high-rate telemetry transfer from MRO and TGO. during the dead zone. The logs confirmed that the time for the transfer was used and the antennae were pointed correctly. But the public-facing logs for the resulting file size, transferred to the publicly maintained archive, were often blank or showed suspiciously low values. The time was accounted for, but the data was not. This created the immediate question: where did the bandwidth go? Furthermore, this protocol extends a crucial layer of plausible deniability. Should the data ever be released with a significant lag, the official explanation will be simple and irrefutable. We were legally prohibited from working on non-essential tasks during the lapse in appropriation. The data sat securely in storage. This mundane explanation, compliant with the Anti-Deficiency Act, is the perfect shield against accusations of a cover-up, even if the sequestered files revealed definitive evidence of unidentified movement or a metallic core. The knowledge of the object's true nature is now contained within this tiny loop of isolated access. A few flight controllers, a few DSN engineers, and potentially a few analysts in non-furloughed agencies like the Department of Defense who retain classified access to DSN assets. It is this legally mandated quietude that forms the core of the mystery. The silence wasn't accidental. It was procedural, and procedure, in this case, proved to be the most effective mechanism of total non-disclosure. We must now follow the path of the data packets that did get through and analyze the specific protocol failure that occurred at the very moment of observation. The most direct and immediate evidence of an operational override during the dead zone did not come from NASA silent servers, but from the European Space Agency's public mission logs. Specifically, the documentation surrounding the critical spectroscopic burst from the ExoMars Trace Gas Orbiter, TGO, the TGO downlink. Failure provides a unique technical fingerprint of an apparent unannounced protocol being executed in real time, targeting high-value scientific products. As established, ESA was fully operational and publicly announced its intent to execute a high-resolution spectroscopic campaign using TGO's NOMAD instrument, aimed at determining the chemical composition of the 3I/Atlas coma. This was the moment of maximum scientific tension. The chance to capture the spectral lines that would confirm or deny the presence of exotic elements like highly abundant nickel or other metals, directly addressing the speculation fueled by the spin anomaly. The planned downlink sequence was critical. TGO's primary antenna was scheduled to lock onto the Deep Space Network, DSN, station in Canberra for a brief, high-bandwidth session, a straight pipe designed to funnel the raw, uncompressed spectral data. The session was scheduled for a duration of 180 seconds. This data was the most sensitive product because it would provide the ultimate confirmation of the object's true nature, potentially revealing a massive metallic core or anomalous chemistry, inconsistent with a standard comet. At the 97-second mark of this critical downlink, the high-rate science telemetry channel abruptly, surgically ceased at the European Control Center. Screens displaying the raw spectral data cascade instantly froze, replaced by an error flag indicating loss of science synchronization. A telemetry gap, however, the low-rate housekeeping data, the diagnostic stream confirming the orbiter's continued health, power consumption, and antenna alignment continued flowing normally for the remaining 83 seconds of the scheduled window. This selective failure is the core of the discrepancy, a total system failure, a power surge, a DSN dish mispointing, or solar weather event would typically disrupt all data transmission, affecting both the high-rate and low-rate stream simultaneously. The fact that the low-rate stream, essential for confirming asset survival, remained robust while the high-rate science stream, essential for discovery, vanished, strongly suggests a controlled, technical intervention executed at the point of reception or transmission relay. The most plausible vector for this intervention lies within the DSN's internal architecture. While TGO is an ESA asset, the DSN is a NASA facility staffed during the shutdown by accepted personnel operating under stringent isolated access rules. The DSN employs a sophisticated real-time data processing and routing system. This system includes logic gates that can, under specific, pre-authorized security protocols, reroute data streams based on content or classification flags. Imagine a scenario. not a conspiracy, but a pre-existing contingency plan, where the U.S. intelligence community, fully aware of the scientific community's interest in unidentified movement and exotic composition, had established tripwires within the DSN routing logic if the real-time processing stream detected strong, non-cometary spectral lines, e.g., highly ionized nickel or iron in unpredicted abundance. During TGO's burst, this could have triggered an immediate, automated, unannounced protocol. This protocol would not be designed to delete the data, but to achieve maximum compartmentalization. The high-rate stream would be instantly diverted from the standard ESA-bound server into the secure, internal classified silo, essentially becoming the property of the accepted personnel crew at the DSN. The failure message sent back to ESA would be a generalized loss of synchronization error, a routine technical failure, providing perfect plausible deniability. The direct result: ESA received definitive confirmation that they tried to observe the comet, but the key evidence, the Nomad spectral signature that would either confirm standard comet chemistry or reveal a metallic core, was siphoned off. This data now sits in the black buffer, co-located with the high-rise photometric data that would confirm the spin anomaly. The operational implication is that the cessation of NASA's public communication did not just create a vacuum. It activated a layer of pre-existing, non-public operational control over internationally shared assets. The shutdown acted as the perfect low-profile camouflage for executing an isolated access intervention that would have been impossible to justify during normal, transparent operations. This surgical termination transforms the narrative from one of mere bureaucratic oversight to a deliberate act of informational control. The data exists. It was captured by a sensitive instrument at the moment of peak scientific tension. It was severed precisely when it should have revealed its secrets. This highly technical inconsistency, the survival of the housekeeping data contrasted with the disappearance of the science data, is the clearest signal, yet that the mystery of 3I/Atlas is not about what we failed to see, but about what a select few succeeded in isolating and archiving. The next step is to see how the scientific community, faced with these partial logs and the deep silence, attempted to normalize this impossible behavior. Faced with the profound technical vacuum, the frozen NASA screens, the surgical 97-second telemetry gap from TGO, and the persistent spin anomaly detected in pre-dead zone light curves, the wider scientific community, operating outside the cone of silence, immediately attempted to restore order through the null hypothesis. This process, the immediate rush to explain unidentified movement using only standard physics, is the expected scientific response. But in the case of 3I/Atlas, it became a crucial, deliberate step in minimizing the profound implications of the sequestered data. The primary goal of this intellectual counterswing, or pendulum swing, was to normalize the two key inconsistencies, the anomalous acceleration and the 1.8-hour rotational flicker, by attributing them entirely to natural cometary processes. Regarding the non-gravitational acceleration, the favored explanation immediately centered on anisotropic outgassing. This theory posits that the object's tiny nucleus contains highly localized, powerful jets of material that are venting primarily from one side, acting like an efficient, off-center rocket. This would explain why the resulting thrust was high despite the relatively small size of the observed coma. The material being vented, proponents argued, must be a supervolatile, like carbon monoxide or nitrogen ice, rather than common water ice. These supervolatiles sublimate more efficiently farther from the sun, generating more thrust with less visible dust. This was a technically plausible, though highly specialized, explanation. However, this argument faced a critical discrepancy. The initial spectra taken by ground-based observatories in August, before solar elongation became a factor, showed volatile ratios consistent with solar system comets, with water and cyanogen lines dominating. They did not show the overwhelming signature of supervolatiles required to power the highly efficient jets necessary to explain the observed non-gravitational push. The scientific community was forced to theorize about jets so precisely localized that they were undetectable from Earth, yet powerful enough to measurably alter the trajectory of a massive object. The other major technical headache was the spin anomaly, the persistent 1.8-hour oscillation. The normalizing explanation here focused on structural fragmentation or chaotic tumbling. Perhaps, the theory went, a piece of a nucleus had recently broken off, and the primary body was now tumbling chaotically, generating complex light curves that mimic a short, structured period. Or perhaps the comet's shape was far more elongated and its density far lower than the initial Hubble estimates suggested, creating a highly unstable rotation state. This attempt at normalization, while scientifically rigorous, exposed the profound operational flaw created by the shutdown. The definitive data needed to falsify these complex natural explanations was precisely the data locked away in the NASA classified silo. The sequestered high-rise photometric data, collected during the dead zone, would confirm the true nature of the 1.8-hour period. If high-rise captured a highly precise, low-noise signature of that period persisting over multiple orbits, it would argue strongly against chaotic tumbling and for a stable, potentially structured rotation. Similarly, the lost TGO nomad spectra would have definitively revealed the composition of the outgassing material, proving whether the anomaly was due to exotic super volatiles, natural, or, conversely, was entirely non-cometary, highly anomalous. The scientific benefit of this investigative framework, the careful examination of the anomalies against the normalization attempts, is immense, and it holds clear lessons for future interstellar object (ISO) encounters. First, the value of redundancy and transparency must be prioritized over bureaucratic compliance. The fact that the full truth of 3I/Atlas now relies on the delayed release of NASA's accepted personnel data, rather than on the immediate, verifiable data from an international partner, highlights a critical failure in international protocols. Future ISO campaigns must include pre-negotiated data release agreements that supersede national government shutdowns. Second, the necessity of an ISO rapid response framework. The ability to catch unidentified movement requires immediate, multi-instrument follow-up. The delay caused by the NASA shutdown, even if administrative, cost the scientific community its only pristine view of the object during its most active phase. Future assets, particularly large aperture telescopes like the Vera Rubin Observatory, must have unannounced protocol templates specifically pre-approved to observe, track, and share data on any newly discovered hyperbolic object within the 24-hour window. Third, the importance of archive integrity and metadata verification. For the public and the scientific community, the immediate action upon the lifting of the shutdown is not to seek sensational claims, but to check the FITS file's metadata. We must look for evidence of the isolated access protocol in the logs. Are the file creation timestamps consistent with the observation times? Are there large, unexplained telemetry gaps in the MRO download logs that directly correspond to the critical 97 seconds of the TGO failure? The mundane work of verifying file integrity and download volumes is the only way to expose if the silence was merely administrative or a calculated act of compartmentalization. The pendulum swing back toward normalcy is a scientific imperative, but it is ultimately incomplete until the sequestered data is released. The scientific community needs the high-rise light curves to explain the 1.8-hour spin anomaly. It needs the TGO spectra to confirm the outgassing composition. Until then, the possibility remains that the data collected during the dead zone confirms that 3I/Atlas performed something genuinely impossible for a natural comet, something that transcends the simple physics of ice and dust, and that profound uncertainty, that persistent discrepancy between the natural theories and the isolated, unverified data, is the final, most unsettling legacy of the Great October Blackout. The attempts to normalize the spin anomaly were immediately complicated by the brief, but highly alarming, appearance of a peculiar chemical signature in the early spectroscopic data, weeks before the dead zone, as 3I/Atlas was still inbound. Select ground-based observatories managed to capture low-resolution spectra of the comet's coma. While the dominant lines confirmed the presence of expected cometary volatiles, cyanogen, water, carbon, there were sporadic, faint, yet statistically significant lines corresponding to ionized heavy metals, specifically neutral nickel, Ni, and iron, Fe. To the uninitiated, the detection of metal in a comet might seem like definitive proof of a dense, non-cometary core. However, this is the realm of scientific nuance. Trace metals are routinely detected in the comae of solar system comets. They originate from silicate dust grains, which contain minor metallic inclusions. When these grains are heated by the sun and vaporize, they release these trace metal atoms. The key is the abundance ratio and the distance from the sun. Metals typically appear only when comets are very close to the sun, inside $1 Australian, where temperatures are high enough to vaporize silicates. 3I/Atlas, however, was detected to be active far outside $1 Australian, and the measured Ni, and Fe lines were deemed inconsistent with standard cometary vaporization models for that distance. The metal abundance appeared disproportionately high relative to the dominant volatile lines. For this to occur naturally, the comet would need to be either A. highly enriched in metals, suggesting an origin from the core of a differentiated planetesimal, a rare but natural possibility, or B. generating extreme, localized heat far exceeding solar input at that range, an almost impossible scenario. This discrepancy immediately sparked private concern within the dynamics community. A small, metal-enriched core would perfectly explain the unidentified movement. The slight, unexplained non-gravitational push, a denser object would require less venting mass to achieve the observed acceleration, thus resolving the conflict between the small visible coma and the strong thrust. The spin anomaly would then be a function of the comet's high density and structural rigidity. The hypothesis shifted. 3I/Atlas was not a fuzzy ice ball, but a heavy, metallic bullet shrouded in a thin layer of escaping ice. Crucially, the raw files containing the most prominent of these metallic lines were quickly withdrawn from the public preprint servers and placed into a specialized, restricted archive. The official rationale cited was the need for extensive recalibration. Due to potential instrument artifacts, this sudden act of compartmentalization, the swift removal of the most intriguing chemical data, occurred just days before the government shutdown was finalized. This removal was not merely a scientific pause. It was an act of operational security. If the data were truly just an instrument artifact, a simple correction note would suffice. The decision to completely pull the raw FITS files and place them under isolated access suggests that the finding was considered too sensitive for public discussion during the volatile pre-shutdown period. This was the first non-bureaucratic indication that the object possessed characteristics that were politically and perhaps militarily sensitive. A large, dense, metal-rich object on a hyperbolic trajectory is not just a scientific curiosity. It is a unique, irreplaceable resource target, and potentially, if the density calculations hold, a significant unidentified movement hazard. The TGO Nomad instrument, the very one whose downlink was surgically terminated at the 97-second mark, was the primary tool intended to resolve this Ni, and Fe mystery. It would have provided definitive, high-resolution spectra during the comet's closest approach, confirming whether the metal lines were real or merely artifacts of distant, difficult ground observation. The surgical termination of the Nomad stream ensures that the high-fidelity chemical confirmation remains locked within the classified silo, co-located with the high-rise data confirming the spin anomaly. The full sequence of events now suggests an elaborate, if accidental, system of non-disclosure. The object arrives with suspicious chemical signatures. The data is immediately pulled under the guise of recalibration. The observation window arrives. The public eye is legally closed via the shutdown. And the one international data stream that could verify the chemical anomaly is surgically terminated a U.S.-controlled relay. The sum of these discrepancies paints a picture of controlled release. where every piece of information that would suggest 3I/Atlas is not a normal comet has been subject to an unannounced protocol of immediate archiving and isolated access. The silence surrounding the chemical composition is now as loud as the bureaucratic silence of a shutdown itself, demanding that we look beyond mere coincidence and analyze the physical mechanisms that were subtly altering the object's path. The orbital nudge. The informational void surrounding 3I/Atlas is largely attributed to the NASA shutdown, but that only accounts for the civilian data. A profound and entirely separate layer of compartmentalization exists within the realm of non-furloughed government agencies. The military, intelligence, and national security space sectors, often collectively referred to as the black budget. These assets, operating continuously, fully funded, and with capabilities often exceeding their civilian counterparts, were almost certainly tracking the interstellar visitor, ensuring that the most sensitive data remains locked in a classified silo. The tracking of deep space objects falls under the mandate of Space Domain Awareness (SDA), primarily governed by the U.S. Space Force and the National Reconnaissance Office (NRO). Their mission is to monitor all assets and potential threats in Earth orbit and beyond, an object traveling on a hyperbolic trajectory at immense speed, exhibiting unidentified movement, and potentially harboring dense metallic composition would be immediately flagged as a high-priority tracking target. These agencies possess an array of sensors that were highly advantageous during the dead zone, while NASA's MRO was struggling with the high angular speed and distance of 3I/Atlas. The NRO operates specialized optical arrays and radar systems designed for wide-field, deep space surveillance. These systems prioritize sensitivity and rapid positional determination over scientific spectral analysis. The potential for radar detection, in particular, becomes a critical point of speculation. While the distance to 3I/Atlas, 30 million kilometers, makes active radar ranging exceedingly difficult for standard planetary systems, the hypothesized high-density metallic core linked to the strange Ni, I, and Fe-I chemical signature could have provided a much stronger radar cross-section than a porous ice comet. If 3I/Atlas was indeed a metallic fragment, the powerful deep space tracking radar operated by the military could have achieved a return, yielding precise distance and velocity data unavailable to civilian optics. This military data, if collected, would bypass the entire NASA public structure. It would be routed directly into a secure archive, the true classified silo, governed by national security protocols. This mechanism achieves total, permanent non-disclosure. There is no accepted personnel loophole here. The data is classified by default, and its existence is generally never acknowledged. The operational benefit of this isolated access to high-fidelity positional data is clear. Any true inconsistency in the object trajectory, any unexplained deviation from the predicted path, would be immediately apparent to defense analysts running highly refined orbital mechanics models. They would be the first to know if the object's slight, unidentified movement was merely outgassing or something far more complex. Furthermore, the military apparatus retains silent control over certain shared infrastructure. The DSN, which handled the crucial TGO downlink, is jointly utilized. It is entirely plausible that the 97-second surgical termination of the ESA science stream was not executed by a furloughed NASA technician, but by a non-furloughed military liaison operating under an unannounced protocol. A specific instruction to compartmentalize any data confirming the suspected metallic or technological nature of the object. The resulting telemetry gap was the public-facing effect of a military-grade data interception. The political dimension of this classified silo lies in the motivation. If 3I/Atlas is a dense, metal-rich fragment, it represents an immense, unique resource, a scientific and economic prize, allowing the public confirmation of its composition and the analysis of its trajectory to be fully open during a highly volatile time, like a government shutdown, could be viewed as a national security risk, particularly in the context of the burgeoning space resource industry. The military data provides a definitive, proprietary knowledge base regarding this interstellar asset. The challenge for our investigation is that we cannot directly access this classified silo. We must rely on an indirect discrepancy analysis. When the post-conjunction orbital elements are finally published by the Civilian Minor Planet Center, MPC, we must compare them to the pre-dead zone predictions. If the new orbital fit is suddenly, dramatically more precise, if the margins of error shrink far more than can be accounted for by the limited number of civilian observations, it would serve as strong circumstantial evidence that a high volume of highly accurate, non-public positional data was injected into the model. This ghost data would be the faint, telltale signature of the black budget tracking effort. The shutdown provided the perfect curtain. While the world focused on the drama of furloughed scientists, the national security apparatus quietly performed its own observations, ensuring that the most valuable information about the third interstellar visitor, the evidence of its density, its strange chemistry, and its slight, unsettling, unidentified movement, was safely and legally locked away in a secure, inaccessible archive. The true nature of 3I/Atlas is not lost, it is merely awaiting declassification, possibly years or decades from now. The next logical step is to isolate the mathematical fingerprint of its anomalous path, the subtle, persistent push that defied simple physics. The most objective, non-sensational piece of evidence suggesting 3I/Atlas was performing unidentified movement is purely mathematical. The persistent, measurable non-gravitational acceleration, or the orbital nudge, embedded within the object trajectory fits. This subtle but statistically significant force defied easy attribution to the simple outgassing models favored by the pendulum swing. When tracking a comet, orbital dynamicists first calculate its path based purely on the gravity of the Sun and the major planets. If the object's actual observed position consistently deviates from this purely gravitational prediction, the difference is accounted for by non-gravitational parameters, A1, A2, A3. These terms model the faint, rocket-like thrust generated by the sublimation of volatile ices. For a normal comet like 2I/Borisov, these parameters are small and neatly align with the object's brightness and observed coma size. For 3I/Atlas, the initial post-discovery orbital solutions revealed a distinct inconsistency. The required non-gravitational force, primarily along the comet's radius vector, A1, was significantly higher than predicted for an object of its estimated size, brightness, and distance from the Sun. As noted earlier, the thrust was disproportionate to the visible coma, leading to the highly specific, normalizing, but unsatisfying explanation of supervolatile, highly localized jets. However, the real technical alarm was the irregularity of the force vector. In a standard comet, the outgassing thrust is generally stable and directed away from the Sun. The orbital solutions for 3I/Atlas exhibited subtle, short-term fluctuations in the A2 parameter, the force component perpendicular to the orbital plane. These tiny, lateral wobbles or nudge events had no clear correlation with solar heating or known rotational periods. They hinted at a non-propulsive, or at least non-standard, mechanism driving the object. This is the mathematical fingerprint of unidentified movement. It's not a massive, sudden change in velocity, a delta-v maneuver, which would be instantly detectable. It is a persistent, low-level discrepancy that accumulates over time, suggesting the object is reacting to forces other than simple outgassing. The dead zone observations were crucial because the object was experiencing maximum thermal stress and acceleration just before and during its perihelion passage in late October. The high-precision photometric data from Embro's high-rise camera, the data currently locked in the isolated access protocol, was intended to precisely track the object's angular position during these peak acceleration events. By correlating the precise position with a 1.8-hour spin anomaly confirmed in the high-rise light curves, scientists hope to determine if the lateral nudge occurred every time a specific structural feature or jet faced the Sun. But the silence from NASA and the surgical termination of the TGO spectrum meant that the crucial input for refining these orbital parameters, the definitive, high-resolution positional data, was missing from the public domain. This forced the civilian orbital dynamicists to rely on incomplete, Earth-based observations taken under highly degraded conditions due to low solar elongation. The result was a public orbital solution riddled with larger-than-acceptable uncertainty margins. The unnerving possibility, as discussed in the context of the classified silo, is that the military or intelligence sector obtained the necessary high-fidelity positional data using specialized sensors, perhaps the deep space radar return from the metallic core hypothesis. If this non-public data was subtly injected into the final orbital fits, not to reveal its source, but simply to provide a more precise, stable trajectory for tracking purposes, it would explain a sudden, post-shutdown shrinking of the official uncertainty margins. This would be the ghost data anomaly, an unnaturally refined orbit achieved without the public release of the corresponding observations. The ultimate test of the orbital nudge will come with the post-conjunction data, which we will discuss later. But for now, the objective truth remains that the third interstellar visitor is following a path that cannot be entirely explained by the natural physics of an icy comet. The residual force vector, the slight lateral wobble, remains an inconsistency that points toward either an incredibly dense, structurally rigid metallic core consistent with a brief Ni chemical signature, or a far more exotic, highly non-natural origin. The legal and bureaucratic silence of the shutdown, therefore, did not just mask the immediate observation. It fundamentally corrupted the public's ability to verify the object's long-term behavior by cutting off the definitive high-resolution data stream at Mars. The unannounced protocol successfully ensured that the mathematical signature of the unidentified movement would remain ambiguous in the public archive, while the true, precise trajectory data was safely compartmentalized within the secure confines of the black budget. We must now turn this analytical scrutiny upon the hypothesis itself and ask why the system was so perfectly structured to prevent the very confirmation of an artificial origin. The confluence of anomalies, the high-density implications of the Ni chemical signature, the precise 1.8-hour spin anomaly, and the statistically significant orbital nudge pushes the investigation squarely into the realm of the extraordinary. For any scientist operating with a responsible level of skepticism, the immediate question is not, is it alien, but rather, does this object pass the falsification test for a technological artifact? The unfortunate reality is that the data sequestered during the dead zone is precisely the data required to either pass or definitively fail this test. The extraordinary hypothesis that 3I/Atlas is an engineered or non-natural technological object demands extraordinary evidence. The scientific process, operating under Occam's razor, must first exhaust all mundane explanations. However, the operational reality of the shutdown and the resulting compartmentalization means that the system actively prevented the peer review community from exhausting those mundane explanations. Let us define the criteria necessary for 3I/Atlas to fail the technological hypothesis, to be successfully falsified as an artifact. 1. Rotational falsification. The 1.8-hour spin anomaly must be proven to be chaotic, unstable, or a result of highly irregular density. Consistent with a tumbling rubble pile, the high-resolution photometric data from MRO's HiRISE camera, currently in the isolated access protocol, is the only dataset sensitive enough to resolve the stability of this period. If HiRISE showed a persistent, high-Q quality factor, rotation over the critical observation week, that argues against a chaotic natural body and for a structurally stable, potentially engineered object. 2. Chemical falsification. The spectral analysis must definitively prove that the outgassing material is composed of supervolatiles, CO, N2, and typical silicates, and that the Ni, I, and Fe lines were merely instrument artifacts or expected trace levels, the high-fidelity spectra from TGO's NOMAD instrument, which was surgically terminated during the downlink. is the only means to achieve this falsification. The continued archiving of this data preserves the ambiguity around the metallic composition. 3. Dynamic falsification. The orbital nudge must be proven to correlate perfectly with the outgassing models and the observed coma asymmetry. If the unexplained delta V, change in velocity, is perfectly smooth and anti-solar, the natural explanation holds. If the nudge continues to exhibit non-radial, lateral wobbles without a visible, correlating jet fan in the high-rise imagery, the force is unidentified movement, and the object fails the dynamic falsification test. The problem, therefore, is systemic. NASA's shutdown was so perfectly timed that it effectively created a protocol of ambiguity by cutting off the public stream precisely when the three key falsification datasets were collected: high-rise photometry, TGO spectroscopy, and MRO astrometry. The U.S. system ensured that the object could not be definitively labeled as either natural or artificial. Why would NASA or a non-furloughed intelligence agency desire this ambiguity? The answer lies in risk mitigation and the strategic value of the unknown, an object that is confirmed to be a metallic core fragment from another star system. Hypothesis 2 is a scientific and economic asset that triggers massive international competition, an object that is confirmed to be a technological artifact. Hypothesis 3 triggers an immediate global political and social crisis for which no nation is prepared. By placing the data into an unannounced protocol, a secure, internal review loop, the small circle of accepted personnel and intelligence analysts gained crucial months to privately assess the true nature of the object without triggering public panic or international legal disputes. The shutdown provided the cover to transition the object status from a scientific curiosity to a strategic anomaly, requiring isolated access and profound compartmentalization. The very act of observing 3I/Atlas with high-resolution instruments during the dead zone, despite the shutdown, confirms that NASA internally viewed the object as a high-risk, high-reward target. They had a look because the potential for a non-natural discovery was real, fueled by the precedent of 1I/Oumuamua. But the legal constraints of the shutdown provided the perfect, plausible excuse for why the results, if truly extraordinary, were immediately locked into the classified silo. The final and most concerning aspect of this failure to falsify is the long-term impact on trust, the discrepancy between what the public was told routine shutdown and what the operational data logs suggest, surgical data rerouting, has permanently eroded confidence. If the eventual data release is delayed, incomplete, or highly edited, the public will correctly assume that the extraordinary evidence was found, judged too sensitive, and permanently placed into a secret archive. The true scientific legacy of 3I/Atlas may not be its origin, but the way its observation exposed the fragility of scientific transparency when confronted with an object that potentially challenges the most fundamental assumptions of life and physics. The shutdown was the key that locked the most important set of observations behind the legal wall of the Anti-Deficiency Act, transforming a public discovery into a deeply compartmentalized secret. The mystery of 3I/Atlas does not begin with the October shutdown, nor does it end with the sequestered high-rise data. To truly grasp the object's anomalous nature, one must apply the painstaking methods of pre-covery analysis, delving into the vast, publicly accessible archive of legacy infrared space missions. This deep dive reveals a subtle, yet profound, inconsistency. A thermal ghost image suggesting that 3I/Atlas was far more unusual and active than initially reported. The key targets for this retrospective search were the archives of NASA's Wide Field Infrared Survey Explorer, WISE, and the Spitzer Space Telescope. Both missions collected comprehensive, long-term infrared maps of the sky, capturing thermal signatures that are often invisible to optical instruments like the Atlas survey system, which made the initial discovery. WISE, in particular, scanned the entire sky multiple times, providing a rich, searchable record of objects moving through the solar system. Working backward from the refined orbital elements calculated in late summer, dedicated amateur astrodynamicists and retired NASA analysts began systematically querying the WISE and Spitzer archives. They searched for faint, moving thermal sources corresponding to the calculated past positions of 3I/Atlas, aiming to extend its observational arc prior to the July 2025 discovery. The success was significant, but the finding was deeply unsettling. The pre-covery data, primarily from WISE's 4.6 micrometers band, showed that 3I/Atlas had been visible in the thermal infrared as early as late 2024. More importantly, the object's calculated size, derived from its thermal emission, was dramatically inconsistent with the size derived from the Hubble optical data. Here is the central discrepancy. Optical observations measure reflected sunlight, which primarily constrains the size of the coma or dust cloud. Thermal infrared, however, measures the heat radiated by the nucleus itself. The WISE data suggested a nucleus size that was both larger than the typical estimates and, more critically, warmer than expected for an object at that distant range. Tilde operator for AU. This thermal anomaly implies two possibilities, both of which argue against the simple, natural comet favored by the pendulum swing. 1. Low albedo and high density. If the nucleus were truly as small as the optical data suggested, the excessive thermal emission means the object's surface, its albedo, reflectivity, must be extraordinarily low, meaning it absorbed almost all the incoming sunlight. This is consistent with a dense, dark, possibly carbonaceous or metallic structure, directly supporting the high-density hypothesis driven by the Ni chemical signature. 2. Internal heating/activity. Alternatively, the excessive heat could be due to a continuous, low-level internal energy source, or an unusually active surface that was generating heat disproportionate to the distance from the sun, while natural mechanisms like internal crystallization or radioactive decay exist. The magnitude of the thermal output was highly inconsistent with a typical 1 to 2 kilometers icy body. This subtle, persistent heating could itself be the source of the slight, but unexplained, unidentified movement, a kind of steady, low-energy outgassing that defied the classic, impulsive jet models. The implications for the dead zone data are immense. The infrared archive clue confirms that 3I/Atlas was anomalous long before it reached Mars. It was already a hot, dark, structurally dense object, highly resistant to the chaotic fragmentation of a normal comet. This information, if fully processed before the shutdown, would have elevated the object's status from a curiosity to a strategic anomaly. The tragedy is that this retrospective analysis relies on data collected months before the dead zone. The key missing piece remains the thermal and chemical data from the Mars window. The MRO carries the thermal emission spectrometer, TES, and Mars Express carries the planetary Fourier spectrometer, PFS. Both instruments are capable of capturing detailed thermal profiles. Were these instruments tasked during the dead zone? The answer is sequestered in the isolated access protocol. If MRO's TS data confirmed the high-temperature anomaly seen by WISE, it would have provided definitive proof of the object's non-standard internal energy state. This data, highly technical and residing in the classified silo, is perhaps the most convincing evidence of unannounced protocol. It confirms that the object was exhibiting a thermal discrepancy that required specific, non-public attention, long before the 97-second telemetry gap at the DSN. The WISE archive has provided the initial, historical proof of the object's strange nature. It is the technical groundwork that transforms the speculation of alien technology into the scientific classification of structurally anomalous, high-density transit. Now, the pressure intensifies on NASA and ESA to release the synchronous thermal and astrometric data from the Mars window, which will confirm whether the slight orbital nudge was the result of a subtle thermal leak from a dense core, or something far more unnerving. The silent history of 3I/Atlas is proving to be as strange as its close encounter. The true measure of the informational crisis surrounding 3I/Atlas lies not in the data that was missing, but in the irreconcilable discrepancy between the few data points that were publicly available and the expected scientific reality. This data group contrast exposes a logical failure in the public record, strongly suggesting that the sequestered data must contain information that fundamentally contradicts the official natural comet narrative promoted by the pendulum swing. The publicly verifiable data pool is extremely small, confined almost entirely to the ESA archive and generalized orbital information from the Minor Planet Center, MPC, derived mostly from pre-dead zone ground observations. Group A, the public ESA data, operational integrity. ESA publicly confirmed their mission operational logs were healthy. Mars Express and TGO successfully acquired lock on 3I/Atlas. They confirmed proper pointing angles, instrument function, and a steady stream of low-rate housekeeping data. This data group proves the opportunity was seized. It proves the instruments were looking at the right time. Crucially, the public record contains the TGO log indicating the surgical 97-second telemetry gap. For the high-rate science data, this absence is the single most important public flag of an unannounced protocol override. Group B, the sequestered NASA data, the necessary contradiction. This group includes MRO high-rise photometry, spin anomaly, MRO astrometry, orbital nudge verification, and MAVEN plasma readings. This data is currently in the classified silo, justified under the Isolated Access Protocol. The logical failure arises when we cross-reference Group A and B with the established scientific anomalies. The logical inconsistency of the spin anomaly. The pre-dead zone light curve showed the persistent, highly precise 1.8-hour spin anomaly. If this anomaly were caused by chaotic tumble, the favored natural explanation, it would be an unstable rotation state, prone to dampening or changing rapidly due to outgassing torques. To maintain stability, the object would need to be exceptionally rigid, highly dense, and structurally integrated, a description inconsistent with a typical porous comet, but highly consistent with the high-density model derived from the infrared archive clue and the NI chemical signature. The logical problem. If the MRO high-rise data, Group B, confirms the stability and persistence of the 1.8-hour period over the 7-day dead zone, it essentially falsifies the chaotic tumble explanation. A stable, rapid rotation in a seemingly small object suggests a profound structural integrity and high mass, which the public data, Group A, currently has no way to explain. The release of Group B data, if it confirms stability, would force the public scientific community to openly debate the existence of an object with non-standard physics. The only way to maintain the pendulum swing towards normalcy is to either indefinitely archive the high-rise data or release it with corrupted metadata. The logical inconsistency of the orbital nudge. The analysis of the orbital nudge showed short-term fluctuations in the lateral force vector, A2, hinting at non-radial unidentified movement. If the object were a normal comet, this lateral force should correlate with visible, powerful jets. The logical problem. MRO high-rise, Group B. Images, if they exist, must show the source of this lateral push. If the high-resolution images show no corresponding localized jet activity where the orbital dynamics indicate an A2 nudge occurred, the data would falsify the outgassing explanation. The community would be left with a verifiable, non-gravitational, non-propulsive force being applied to the object. This would immediately trigger a massive reevaluation of the object's status. The most effective way for the unannounced protocol to prevent this is to isolate and compartmentalize the visual evidence that contradicts the trajectory model. The logical inconsistency of the TGO gap. The TGO's spectral measurement, Group A log confirming failure, was precisely targeting the chemical composition. This was the only way to falsify the metallic core hypothesis. The logical problem. The surgical nature of the 97-second telemetry gap, contrasted with the robust housekeeping data flow, strongly suggests the DSN detected a trigger condition. Given the prior concern over the NI signature, the trigger was likely chemical. If the sequestered NOMAD data, now in Group B, contains high-fidelity confirmation of non-cometary chemistry, its release would retroactively prove that the telemetry gap was a deliberate isolated access maneuver, destroying the claim of accidental silence. In essence, the small public data set, Group A, provides the coordinates, the timing, and the clear anomaly flags. Spin, nudge, the sequestered NASA data, Group B, holds the definitive falsification test results. The continued silence surrounding Group B data, while after the nominal end of the initial administrative blackout, is the strongest possible confirmation that the results of the falsification test were problematic. The data group contrast reveals a situation where the data that did exist creates a logical certainty that the data that was hidden must contain a profound contradiction to established science. The silence is not the result of a lack of findings. It is the deliberate archiving of a finding that is too structurally sensitive to release. The focus must now shift to the subtle methods used to corrupt the temporal accuracy of the public record. Beyond the outright telemetry gap that severed the TGO science stream, a more subtle, pervasive operational failure occurred during the dead zone, one that has created lasting discrepancy in the public archive: the systemic corruption of the spacecraft time signature synchronization. This synchronization failure is a critical, technical fingerprint of the unannounced protocol, proving that the precise timing of events, a non-negotiable requirement for validating unidentified movement, was intentionally muddied during the informational blackout. In deep space operations, every piece of data, be it an image, a spectrometer reading, or a telemetry point, is useless without an accompanying, highly accurate timestamp. Spacecraft clocks drift, so they must be constantly synchronized with the Deep Space Network, DSN, master clock using two-way ranging and precise time protocols. This synchronization is crucial for astrometry. To confirm an orbital nudge, one must know the object's exact position at a specific millisecond. The issue that arose during the dead zone was not a failure of the physical clock on the orbiters, but a failure of the ground processing protocol for time synchronization. Under normal NASA operations, the raw data packets arriving at the DSN are immediately merged with a high-fidelity clock correlation file, creating the final, verifiable fits files that include precise time metadata. During the shutdown, this sophisticated processing pipeline was compromised. The furloughed personnel included the specialized clock correlation engineers and the software teams responsible for generating the highly accurate time correlation files. The accepted personnel at the DSN, whose mandate was asset safety, maintained only the basic time logs, the low-fidelity housekeeping data sufficient to keep the spacecraft functioning, but inadequate for high-precision science. The resulting synchronization failure meant that the high-rise photometric sequences, Group E data, and the residual TGO low-rate data, Group A data, that did make it into the archive possessed timestamps with significantly higher uncertainty margins than standard operations. This increase in time uncertainty is a powerful tool for maintaining ambiguity. If the timestamp on a high-rise image is off by just a fraction of a second, the apparent position of the fast-moving 3I/Atlas shifts significantly in the celestial sphere. This shift can be mathematically interpreted as error, or, more conveniently, it can be used to artificially smooth out the very discrepancy we are looking for: the subtle, irregular lateral wobble of the orbital nudge. If the intelligence community needed to normalize the anomalous trajectory, a process consistent with a black budget effort to achieve a stable tracking solution without revealing its source, artificially increasing the time uncertainty margin in the publicly releasable data would be a perfect tool. A larger uncertainty margin can legally absorb the unidentified movement into the noise, making the trajectory appear more stable and predictable. Furthermore, the synchronization failure directly compromises the validation of the 1.8-hour spin anomaly. To prove the stability of such a short period, astronomers must track its phase precisely across multiple orbits over several days. If the timestamps are imprecise, the rotational phase alignment fails, and the precise, structured nature of the spin is lost to noise. The scientific conclusion then defaults back to the normalized explanation: chaotic tumbling, thus supporting the pendulum swing. The crucial evidence for this protocol failure is not what is missing, but what is degraded. When the MRO data is eventually released, investigators must look closely at the metadata uncertainty flags within the FITS files. If the official error margins for the timestamps during the dead zone are disproportionately high compared to the preceding September data, it serves as undeniable technical proof of the unannounced protocol. This isn't just bureaucratic sloppiness. It's systemic informational sabotage. The Anti-Deficiency Act provided the plausible legal cover. We lack the personnel to maintain high-precision clock correlation. But the effect is deliberate compartmentalization. The very element of precision required to confirm the extraordinary is surgically removed from the public record. The synchronization failure, therefore, confirms the hypothesis that the silence was not just about hiding a discovery, but about actively degrading the quality of the evidence, so that even if the sequestered data, Group B, is eventually released, the key inconsistencies, the non-gravitational dynamics, and the stable short-period rotation, will have been mathematically washed out, permanently archived as simple measurement error. This technique of corrupting the temporal record is the ultimate expression of isolated access, allowing the physical data to exist, but denying the public the precision needed to understand it. The story of 3I/Atlas is now the story of a cosmic anomaly protected by corrupted time. The unfolding narrative of 3I/Atlas. The surgical telemetry gap, the NI chemical signature, and the corrupted time signature presents a perfect case study in modern government secrecy. It demonstrates that the most effective form of non-disclosure is not a dramatic, high-stakes conspiracy involving men in black, but a mundane, pre-existing, unannounced protocol rooted entirely in bureaucratic procedure. This procedural silence is far more durable and defensible than any elaborate cover-up. To understand why the public remains ignorant of the true findings, we must analyze how the Anti-Deficiency Act became the ultimate shield for compartmentalization. The key principle is that the procedural framework of the shutdown was leveraged to achieve a desired outcome: isolated access to sensitive data, without committing a single illegal act of overt censorship. The traditional definition of a conspiracy requires a direct, malicious intent to deceive the public regarding a known fact. However, in the 3I/Atlas case, the silence is governed by the following operational realities. 1. The legalization of non-disclosure. The Anti-Deficiency Act legally prohibits furloughed scientists from working. It equally prohibits the expenditure of money, and thus labor, on activities deemed non-essential, such as maintaining public image archives or writing press releases. This means the core discrepancy, the gap between collected data and public communication, is legally compliant. The silence is not a lie. It is a legally mandated consequence of a funding mechanism. This provides ironclad, plausible deniability. We would have told you, but the law prevented us. 2. The preemptive protocol. The most sensitive interventions, the surgical termination of the geoscience stream of the DSN and the routing of high-rise data into the classified silo, did not require a sudden, risky high-level order. They only require the activation of pre-existing security or emergency protocols. The DSN, as a jointly used asset, always maintains the technical capability to reroute high-bandwidth streams based on internal security parameters. If the unannounced protocol was simply a standing order to secure and archive any anomalous spectral data during a crisis period, the accepted personnel merely followed a pre-approved script. This decentralizes the decision, making it impossible to trace back to a single malicious actor. 3. Compartmentalization by mandate. The few individuals who did handle the data, DSN engineers, MRO flight controllers, were legally bound to their specific non-scientific mandates, asset protection. If a flight controller saw the 1.8-hour spin anomaly in a raw high-rise file, they were legally prohibited from sharing that scientific insight with any furloughed expert. They could only file the data in the isolated access buffer and ensure the spacecraft was healthy. The knowledge was contained, not by secrecy oaths, but by legal jurisdictional walls. 4. Data degradation as concealment. The synchronization failure is the ultimate technical mechanism of secrecy. By allowing the temporal precision of the MRO data to degrade, the unannounced protocol ensured that even if the raw FITS files are eventually forced into the public archive, the mathematical proof of the unidentified movement, the lateral orbital nudge, will be statistically nullified. The data exists, but the ability of the peer review community to verify the anomaly is surgically removed. The power of this procedural secrecy is its sustainability. It requires no lies, only selective omission and adherence to the letter of the law. The pendulum swing back to normalcy is supported not by scientific evidence, but by the legal certainty that any conflicting data has been safely placed in the secure classified silo. The takeaway for the public is clear. When the government goes dark during an extraordinary event, the resulting silence is not an error. It is an operation. The 3I/Atlas incident confirms that space exploration has now crossed a threshold where the potential for detecting non-natural phenomena is high enough to warrant pre-approved, legally compliant mechanisms for total informational control. The data group contrast between the predictable silence, NASA, and the surgical cutout, TGO, is the operational evidence that a high-value anomaly was indeed detected. The most profound realization is that the greatest barrier to the truth is not the exotic nature of the anomaly, but the deeply ingrained nature of bureaucracy. Fighting a secret is hard. Fighting a legal procedure that prohibits the sharing of information is virtually impossible. The fate of 3I/Atlas now rests in the hands of the accepted personnel, the small group of custodians who know what the archive truly contains, and whose silence is perfectly protected by the law. We must now turn our attention to the human reaction, the private, coded communications, and the expert stunned silence that followed the operational blackout, confirming that the scientific community itself knew something extraordinary had been found and sequestered. If the bureaucratic silence of NASA was the operational shield for compartmentalization, the response from the non-furloughed, but highly informed, scientific elite became the most telling human indicator that the sequestered data contained profound inconsistencies. This was the expert stunned silence. Not a legal mandate for quietude, but a deliberate, ethical choice of non-disclosure. Using coded language and the safety of the null hypothesis to navigate the extraordinary situation. Immediately following the dead zone, key figures in orbital dynamics and interstellar object research, those who retained consulting contracts or worked at non-furloughed academic institutions, began issuing statements characterized by extreme caution. These were not the typical enthusiastic pronouncements one expects after a globally significant observation window. They were terse, focused almost entirely on the difficulties of the Earth-based observations, low solar elongation, and conspicuously avoided any direct comment on the performance or preliminary results from the Mars orbiters. In coded scientific language, silence is itself a signal. The usual protocol in a campaign involving international partners like ESA is the rapid, pre-publication exchange of non-sensitive raw data for cross-validation. Yet, in the weeks following the TGO surgical telemetry gap, there was an unprecedented lack of internal, multilateral communication regarding the astrometry and photometry from Mars. This internal discrepancy confirmed that the data had been flagged as highly sensitive before. It could be vetted by international peers. One prominent Harvard astrophysicist, known for his vocal stance on the possibility of artificial interstellar objects, offered a statement that was both compliant and deeply unsettling. When asked about the possibility of an orbital nudge exceeding natural limits, he responded, "The data we currently have access to does not exclude the possibility of non-gravitational forces. We must apply patience and wait for the high-fidelity, high-cadence data to be made available before drawing definitive conclusions regarding the stability of the long-term trajectory." The phrases "currently have access to" and "made available" were the codes. He was confirming that data existed that he did not have access to Group B data in the classified silo, and that the public data, Group A, was insufficient to rule out unidentified movement by simply adhering to the methodological necessity of waiting for the full dataset. He confirmed that the sequestered data held the key to the most extraordinary hypothesis. Furthermore, the lack of immediate aggressive pushback against the metallic core hypothesis was highly significant. Scientific debate is typically fierce and immediate. Yet, after the initial NI chemical signature was placed under isolated access, under the guise of recalibration. The critical community remained muted. No leading figures immediately published strong papers definitively falsifying the metal signature as instrument error. This expert-stunned silence was the tacit acknowledgement that the evidence for a high-density, structurally rigid object, which would perfectly explain the stable 1.8-hour spin anomaly, was strong enough to make open dismissal professionally risky. The academic community's adherence to the pendulum swing, the attempt to normalize the phenomenon, was not a reflection of belief, but a strategy. It was a consensus to stabilize the public narrative until they could acquire the definitive Group B data needed for the final, potentially explosive announcement. They knew that if the high-rise photometry confirmed a stable rotation and the spectral data confirmed the metallic inconsistency, the announcement would have to be handled with extreme care. To prevent global panic, the shutdown, by providing procedural cover, simply bought the system the time necessary to craft that response. The few leaked whispers that did escape this circle invariably pointed to the same technical fault: the synchronization failure. Engineers who worked on the clock correlation protocols privately expressed disbelief at the officially reported high temporal uncertainty of the MRO data during the dead zone. "We haven't seen the kind of clock drift since the 1980s, was the sentiment. This professional incredulity serves as a human confirmation that the degraded time signature was not an accident, but an unannounced protocol for data concealment, a technical form of archiving the evidence of the orbital nudge. In essence, the expert-stunned silence confirmed what the data logs already showed. The key questions about 3I/Atlas. Is it stable? Is it dense? Is its movement explainable by known forces? Were definitively answered during the October blackout. But those answers were deemed too profound for public release. The small group of non-furloughed experts understood that the procedural silence of the shutdown was merely a strategic pause. The universe had delivered an anomaly, and the bureaucracy had responded with a highly effective legal mechanism of isolated access. The next step is the return of the object, the final chance to verify the sequestered truths. The investigation into the dead zone and the sequestered data now pivots from retrospective analysis to preemptive vigilance. The period of informational blackout, dominated by the bureaucratic shield of the Anti-Deficiency Act and the technical obfuscation of the synchronization failure, is drawing to a close. The universe, thankfully, is not subject to government funding lapses, and 3I/Atlas is now scheduled to emerge from solar conjunction. This post-conjunction window, spanning late November and early December 2025, is the reappearance hook, the moment the public scientific community gets its final, unambiguous chance to verify the sequestered truths and check the receipts of the American and European space systems. When 3I/Atlas emerges from behind the sun, it will have completed its perihelion passage and will be receding from our star, moving rapidly back towards interstellar space. This moment is scientifically critical because the object's trajectory will reflect the cumulative effect of all forces: gravitational, outgassing, and the subtle, persistent, unidentified movement it experienced during the intense period of the dead zone. The primary focus of the post-conjunction observation campaign must be the orbital nudge verification. The highly refined orbital solution, currently maintained by the Minor Planet Center, MPC, is based predominantly on pre-dead zone data, relying on assumptions about the non-gravitational parameters. A1, A2. These parameters currently absorb the slight, irregular lateral wobbles, A2, that hinted at unidentified movement. If 3I/Atlas truly possesses a high-density, structurally rigid core, consistent with the NI chemical signature and a stable 1.8-hour spin anomaly, then the slight lateral nudges would have persisted and accumulated. Upon reemergence, the object's position will deviate from the currently published MPC solution by a measurable amount. If that deviation is significant and aligns with the expected accumulation of the non-gravitational anomalies seen in the summer data, it will provide powerful, independent confirmation that the object's dynamics are non-standard. Furthermore, A significant deviation would constitute circumstantial proof that the MRO astrometric data, which could have smoothed out the anomaly, was deliberately withheld or corrupted via the synchronization failure. The discrepancy between the predicted position and the observed position will mathematically demonstrate the consequences of the successful compartmentalization. The second critical task is the chemical and activity verification. As the comet recedes, its activity should naturally wane. However, if the high-density metallic core hypothesis holds, the object's thermal profile, as hinted by the infrared archive clue, might be sustained by internal heat or unique chemical processes, leading to an activity curve that is inconsistent with a typical icy comet. New high-resolution spectroscopy from large ground-based telescopes must target the coma to definitively falsify or confirm the presence of high-abundance metal lines, Ni, If these signatures persist at greater distances, it would retroactively validate the concern that led to the surgical TGO telemetry gap. The reappearance hook is also the final audit of the accepted personnel protocol, when the full batch of NASA and ESA data from the dead zone is finally released. Months after the shutdown, it must be compared against the independent post-conjunction findings. If the released MRO high-rise data confirms a stable 1.8-hour rotation and the post-conjunction orbit shows a significant unexplained deviation, the only conclusion is that the stability of the rotation allowed the accumulation of the orbital nudge. The truth of the anomaly will be confirmed by its compartmentalization. If the officially released data, however, contains metadata that shows severely corrupted time signatures or low-quality astrometry, it will prove that the unannounced protocol was designed not just to delay the data, but to mathematically neuter its scientific value, making the evidence of the unidentified movement legally and scientifically ambiguous. The entire scientific community, including amateur observers, must act as independent auditors during this period. The public archive, Group A data, must be rigorously cross-checked with the eventual release of the sequestered data, Group B. Every inconsistency, every high temporal uncertainty flag, and every unexplained telemetry gap must be noted. The reappearance hook gives us the leverage. The universe offers up the object's true trajectory, the ultimate receipt. If the official post-shutdown data release does not match the observed trajectory, the burden of proof shifts irrevocably to the agencies to explain the discrepancy. This is the final opportunity for the public to break through the procedural silence and uncover what the small circle of accepted personnel truly locked away in the secure classified silo. The lights are coming back on, and the true cost of the informational blackout is about to be measured in kilometers of unexplained deviation. We have traversed the informational vacuum, analyzed the technical failures, and charted the mathematical ghost of unidentified movement. The entire investigation of 3I/Atlas boils down to a single, inescapable synthesis. Was the informational blackout of October 2025 merely a bureaucratic coincidence, or was it a state of necessary concealment? A strategic act of non-disclosure designed to manage a discovery too profound for immediate public consumption? The evidence overwhelmingly points to the latter, framed not by malice, but by operational necessity. The timing of the NASA shutdown, coinciding precisely with the 1 week of peak observation and perfect geometry advantage from Mars, provided the ideal, legally compliant mechanism for enacting a highly sophisticated unannounced protocol. This protocol achieved total compartmentalization of the definitive evidence. Let us review the 3 core pillars of this evidence. 1. The surgical disruption. The TGO downlink failure, with its 97-second telemetry gap affecting only the high-rate science stream, while preserving the housekeeping data, is the fingerprint of external intervention. This suggests the DSN, operating under isolated access rules, detected a trigger condition, likely the highly sensitive Ni chemical signature, and executed a real-time data siphon, routing the definitive spectral confirmation into the classified silo. This act of archiving the chemical truth was the first strike against transparency. 2. The degradation of verifiability. The subsequent synchronization failure in the MRO astrometric data, evidenced by the abnormally high temporal uncertainty margins, serves as the technical mechanism of sustained secrecy. This degradation mathematically nullifies the public's ability to verify the most compelling anomaly, the slight persistent orbital nudge. By corrupting the time signature metadata, the unannounced protocol ensures that even if the high-rise data is released, the evidence of unidentified movement is absorbed into acceptable statistical noise. The data exists, but the ability to prove its anomaly is surgically removed. 3. The logical inconsistency. The data group contrast reveals a situation where the publicly observed anomalies, the stable 1.8-hour spin anomaly and the infrared archive clues high temperature, demand the existence of a highly dense, structurally rigid object, yet the required falsification test data, high-rise light curves, TGO spectra, remain sequestered. The scientific and logical pressure exerted by the public data necessitates that the isolated access data contains proof that contradicts the simple natural comet narrative. The expert stunned silence confirms that this logical conclusion is shared by the highest levels of the scientific community. The conclusion. The events of October 2025 were not an accident. The shutdown provided the necessary legal cover, but the subsequent actions, the surgical cuts, the selective archiving, and the degradation of precision were the result of a pre-approved, unannounced protocol designed to manage a profound truth. 3. I/Atlas exhibited behavior, dynamics, rotation, and potentially chemistry that was highly inconsistent with a porous ice comet. The system reacted by enacting the most secure and legally defensible non-disclosure framework possible. The narrative we are left with is not one of a lost opportunity, but of a successful operation, the successful compartmentalization of a strategic anomaly. The final strike. The ultimate verification now rests with the reappearance hook in late November and December, when astronomers observe the object emerging from the sun. Its actual position will serve as the final auditor. If the object's position deviates significantly from the publicly published trajectory, a deviation consistent with the accumulation of the unexplained orbital nudge, it will provide circumstantial proof of two things. 1. That the force driving the object is non-standard and persistent. 2. That high-fidelity astrometric data capable of masking that deviation was collected and suppressed via the classified silo. This is the central question that we must carry forward. Was the silence of the American government during the encounter with the third interstellar visitor a random stroke of luck that allowed the bureaucracy to function? Or was the shutdown coinciding with the confirmation of a slight, unsettling, persistent, and unidentified movement, the moment the existing legal mechanisms for non-disclosure were finally strategically activated to protect humanity from a truth it was not ready to receive? The fate of 3I/Atlas is now sealed within its own hyperbolic trajectory. The fate of the truth lies within the integrity of the data that will be made available. We must remain vigilant, cross-checking the data group contrast against the objective reality of the object's post-conjunction position. Only then will we know exactly what NASA is archiving about the interstellar traveler that performed the impossible near Mars.